So this is a question from projectile chapter. The question from IIT JEE PYQ JEE Advanced 1996. Sorry, 1994. JEE Advanced 1994. It is a subjective question. Two towers AB and CD are situated at a distance D apart as shown in the figure. AB is 20 meter high and CD is 30 meter high. Okay, from the ground. An object of mass M is thrown from the tower AB. Here a mass M is thrown from the tower AB from this point A horizontally with an velocity of 10 meter per second. So it is being thrown like this, 10 meter per second. Okay. Simultaneously towards the CD, simultaneously another object of mass 2m is thrown from the lay of CD at an angle. Okay, so another mass is thrown. This object mass is 2m and it is being thrown at an angle 60 degree to the horizontal line. Okay, so this is the horizontal line. This angle is given as 60 degree, right, to the horizontal line of AB with the same magnitude of initial velocity as that of the first object. That is, initial velocity is 10 meter per second only, right. The two objects move in the same vertical plane, collide in the mid-air and stick to each other. First we have to calculate the distance D between the two towers. Let us suppose this is the distance D. So here we can directly use the concept of relative velocity. This is our tower A. I will be directly writing the relative velocity concept here. This is our particle A of mass M. So this is our particle A. It is having a velocity of 10 meter per second in this direction. Okay, so velocity of particle A is equal to what? 10 meter per second in I cap direction. Similarly, here is the velocity, this particle B, and it is having a velocity 10 meter per second at an angle 60 degree. So this is 10 meter per second. Okay, so I will resolve it into the components, horizontal and the vertical component. So this will be 5 meter per second and this vertical component will be 5 root 3 meter per second. Okay, so velocity of particle B with respect to ground, that will be equal to negative 5 meter per second I cap minus 5 root 3 meter per second J cap. Okay. Now if I observe the particle B, sorry, this was particle C actually. Now if I observe this particle C from the particle A, then velocity of particle C in the frame reference of particle A, that will be what? That will be V velocity of particle C with respect to ground minus velocity of particle A with respect to ground. Okay, so here VCA, that will be equal to we will be putting the values here, minus 5 I cap minus 5 root 3 J cap minus 10 I cap. So this will be equal to negative 15 I cap minus 5 root 3 J cap. Okay, so this is the velocity of particle C when we are observing in the frame reference of A. Okay, so when this is the particle A, in frame reference of A, particle A will be at rest and this is our particle C. When I am observing particle C from the A, it is having an horizontal component of velocity that is equal to 15 in negative direction, and a vertical component of velocity that is equal to what, 5 root 3 in negative direction. Since it is given in the question that these two particles will be colliding into the vertical plane, then if these two particles have to collide, then their relative velocity should always be along this line joining the two particles along the AC, this direction. Then this velocity of C with respect to A should always be along the CA line. Okay, so since we can easily find out the magnitude of this relative velocity here, that will be what, VCA magnitude, that will be equal to root under this 15 square plus 5 root 3 square. So this will be equal to 15 square is 225 plus this will be equal to 75, that is equal to root under 300, that is equal to 10 root 3 meter per second. Okay, so here we have now we can easily relate these two things, that velocity of this particle along this line is 10 root 3 meter per second. That means when we are observing C from the A, C is approaching towards the A with a speed of 10 root 3 meter per second. Okay, so here I will draw this triangle, like this is our vertical component of the velocity, and this is our horizontal component, and this is the resultant velocity. Okay, so this is our horizontal component of velocity, that is equal to 5 root 3, and this is our vertical component, that is so this is our vertical component, and this is the horizontal component, that is equal to 15 meter per second, and their resultant is 10 root 3 meter per second. Okay. Now we can easily find out what is this angle theta in this triangle, because this is a right angle triangle, and we can easily find out what is the angle theta. So this tangent theta in this vector triangle is perpendicular divided by base, that is equal to 5 root 3 divided by 15. So this will be 3, that is equal to 1 by root 3. So here theta will be equal to tangent theta I will be directly writing only. Tangent theta will be equal to 1 by root 3, or theta we can write as 30 degree. Okay, now coming to our question's first part. This is our tower A, this is our tower B, this is 20 meter high, this is 30 meter high, and this is our point A, this is our point C. Since we are observing this C particle from this A, then their velocity is always in this direction, and we have calculated this angle. Let us suppose this is the D, and this angle is 30 degree. Okay, and this side will be 30 minus 20, that is equal to 10 only. Okay, so now in this triangle, let us suppose this is the point, some point, let us please O. Okay, in this triangle AOC, tangent theta is equal to 10 divided by D, that is equal to tan 30 is equal to 1 by root 3. Okay, so this the value of d we will be easily getting is d, that will be equal to 10 root 3. 10 root 3 meter. Okay. So this is our answer for the first question. This d will be 10 root 3 meter. Okay. Now coming to the second part, we have to find out the position where the objects hit the ground. Okay. So let me draw the diagram here. This is our tower A. This is our ground. This is our tower B. And this is the point A. This is the point C. This is B. This is D. Let us suppose initially particle is coming like this, and this particle is coming like this in ground frame of reference, and they are meeting at this point. Let us suppose this point is O. Okay. So initially this A particle of mass m, and this was having a mass 2m. This was having an horizontal component of velocity of 10 meter per second. Okay. And this was having an horizontal component of velocity, how much? That we calculated here. Horizontal component of 15 meter per second. Horizontal component is 5 meter per second. So 5 meter per second. Since on this system there is no external force in horizontal direction, F external in horizontal direction, that means x direction, is 0. So momentum will be conserved in this direction, horizontal direction. So here we can directly calculate that. Let us suppose the momentum we will apply the momentum conservation in the horizontal direction, that is P initial in the horizontal direction, x will be equal to P final in the horizontal direction, that means x. So when they will collide, they will stick to each other, then their final mass will be 3m. Okay, and let us suppose their velocity is v. Now we will be writing the momentum for individual particles. So for first particle, m into 10, and for second particle our momentum will be negative, because this 5 meter per second is in negative direction, that is 2m into 5. Okay, so 3mv, that will be equal to what? 10m minus 10m, that will be 0. So velocity of these two particles after colliding in the x direction will be 0. So after that they will just fall down here. What we have to find? We have to find this x component only when they will be colliding. How we will be finding this x component? We will apply the directly this concept of relative velocity again here. Since in the triangle we had already find out, like this was our tower A, this is our tower B, this is AB, this is what? CD, and we have already calculated this is the distance D. Okay, and this was 10 meters and this angle was 30. So when I am observing this particle C from A, this is A, this is C, and C is coming towards A with a relative velocity of 10 root 3 meter per second. Okay, with a 10 root 3 meter per second. And let us suppose this distance D. Now we have to find out what is the value of this D. So this D will be equal to d square plus 10 square. Okay, and this D will be what? D square. The value of D was find it before, that is 10 root 3 square plus this 10 square. So d square will be equal to 10 square into 3, that is 300, plus 10 square, that is 100. So this d we will be getting under root of 400, that is 20 meters. So this d is 20 meters. Now this is our particle A, and the distance between them, between particle A and particle C, is 20 meters. And in frame reference of A, particle C is coming towards the particle A with an speed of 10 root 3 meter per second. Okay, so time taken by this particle C to meet this particle A is this distance by this speed, that will be equal to, distance is 20 meter divided by this velocity, that is 10 root 3. So our time will be equal to 2 by root 3 seconds. Okay, so in this time 2 by root 3 seconds, both of the particles will meet. So to find out this x component, like x coordinate where these two particles will meet, we will be just I will be just writing the equations for this particle A in horizontal direction. In horizontal direction there is not any external force. Horizontal direction there is not external force, so acceleration in horizontal direction is 0. So for particle A, x will be equal to initial velocity in horizontal direction into the time period. So initial velocity is what, 10 meter per second, into time period is 2 by root 3. Okay, so our x component will be 2 by 20 by root 3 meters. Okay, so the two particles will be falling after the collision. Like this is our tower A, and this is our tower, this is AB, this is CD. Okay, and these two particles are coming like this, and this is coming like this, and after collision they are just falling down like this. So at this point, this is a point E, they will be colliding, they will be falling down, and this distance x is 20 by root 3 meters, and they will be colliding in how much time? That time is 2 by root 3 seconds. Okay, and the distance between the towers is, that is equal to d, and that d is 10 root 3 meter. 10 root 3 meter. So our answer to all the questions have been completed now. So this was the method we have to use in the questions to solve the problem.